I started this talk being really ambitious and trying to really tell y'all what are all of the best practices for dealing with Apache Beam pipelines in production. And as I was building up the content, I figured out that there's all of them. So I decided to rename it to some good practices for Apache Beam, because we'll review some of them. I also tried to have a little bit of everything for everyone. So, you know, if you're completely new to Beam, you'll be able to follow along. I've added a few slides that will help us, help everyone follow along. There's going to be a little bit of live coding, and so if you go to the repository from the Beam Learning Month that Jamal is sharing, there's the section for webinar 2, and there's going to be the slides, and then there's a GitHub repository called Beam COVID example, and it's a tiny Python project where I wrote a few transforms, a few tests, and you can follow along. All right then. So with that, with the logistical details aside, I'll get started. Who is me? I'm Pablo. I'm a Beam committer and PMC member. I'm a software engineer at Google also since 2016, and all of that time I've been working in Beam. So most of my work in Beam has been on the Python SDK and IO transforms, so reading data for reading and writing data from an Apache Beam pipeline. I've done a little bit of Java also, and recently I've been working on CDC, which is change data capture, which is you change streams from databases and do some streaming analytics of them on your Beam pipeline. All right, so what's the agenda? I'll do a quick introduction to Beam and some of the applications that it has. I'll be very quick. I just want to get the basics out of the way so that we can then look at the basic syntax of the Python SDK, and then we'll start working on an example Beam pipeline and what are the pieces of it, and we'll test them also. All right then. So what is Beam? If you were here last week, you saw that Beam is a unified programming model to implement batch and streaming data processing jobs that run on any execution engine. And well, that's a little abstract, but the idea is that you should be able to write a relatively small program in the language of your choice. So Beam currently supports Java, Python. We have a Go SDK. We have also SQL. So you'll be able to write your pipeline in one of these languages, and then you'll be able to run it in one of the runners that you might be familiar with, such as Flink, Spark. There's Apache Apex, SAMSA, Gearpump, and there's also Google Cloud Dataflow, which is a managed service to run Apache Beam pipelines. And so what do we mean when we say a data processing job? Right? So a data processing job is normally a series of operations that you define in a program where you say, okay, I want to read data from some storage system, and I want to apply certain transformations to it to obtain some insights or some actions that I can execute from it. So when you read data, Beam is able to read data from many storage systems, databases, file systems, message queues, and then with Beam, with the Beam SDK, you express the logical transformations that you want to apply to your data. And finally, once you have applied these transformations to your data, you can write out the data to the results to a database, file system, message queue. You can perform an action, make an RPC to an external system, etc. And so here, one of the keywords is logical, because the key with all of these systems is you only need to worry about the transformations that you want to apply to your data. You'll define them, as I said, in a relatively small program, and then you'll take this program and you'll submit it to a cluster, which can be, again, a Spark cluster, Flink cluster, Cloud Dataflow, etc. And the cluster, Flink, Spark, or whatever, will take care of executing your analysis on, at large scale, right? And so, so the philosophy here is you don't have to worry so much about, how do I run this on 1,000 machines? How do I run this on 100 machines? You would just need to worry about what you want to do to your data, and Beam and your execution engine will worry about how that will be executed. Anyway, so now I said, okay, we have this logical operations, right, and we have these collections of data, right, and so this is the abstract idea that in Beam we implement as two classes, right? So there's a P collection class. A P collection class represents a collection of data. So you'll have an object, which is, for instance, your input data. And so this input data will be a collection of perhaps lines in a file, or messages in a message queue, or rows in a database, right? And then you'll take this data and you'll say, okay, I want to apply this transformation to it. And so these transformations are P transforms. And so you'll have classes that implement this logical operations that you want to apply to your P collections. And you'll say, okay, I want to apply this series of transformations to my P collection. And the output of this series of transformations is another P collection. And I know this is all really abstract. So let's see what this looks like in Beam, right? So this is in the Python SDK. In the Java SDK is somewhat similar. To start, what you do is you create a pipeline object. This pipeline object will be basically your the object that holds all of the set of transformations together, right? And so once you have a pipeline object, you can start defining what will be the analysis that you'll perform on your data. So the first thing that we want to do is we want to read data in from an external system, right? And so in Beam, we'll say, we'll use our pipeline object here, and we'll use this pipe to say, apply this operation, okay? Now this throws people off sometimes, but in the Beam Python SDK, this is how we say apply an operation to this P collection or to this pipeline, all right? So what we're saying in this line is take your pipeline and apply this operation to it, where you say read some data from S3. S3 is a file system on AWS, and so what we're saying is read this file or this set of files from S3 and store it in a P collection a P collection that contains where each element is one line in this file, right? Now, once we have the line in each file, we can take that collection of lines and we can apply some analysis to it. And so let's just go with the simplest analysis. Let's count how many times each word appears, right? And so because we have lines in a file, we want to first get the P collection of all the words, right? So what we do is we take this input data and we apply another operation, right? Now, this operation is a flat map, and what it is we pass in a function where we say for each line coming from this input data, we're going to split it on its white spaces, right? And so this is something that, by the way, is very common in all of the systems. Functional interfaces where you'll say, okay, apply an operation where you apply a lambda to every single element of this collection. Anyway, so we start with a P collection of lines in a file, and then we'll apply this operation to it to get a P collection of words. And then we'll we'll take this P collection of words and we'll just apply some operation called count each, where we'll count how many times each word appears. Right? And so we obtained a P collection of word counts, and finally we could get to BigQuery, for instance, which is a data warehouse that we have in Google Cloud. All right, then. So this is more or less what the Beam pipeline looks like in the Python SDK. So now that we have that out of the way, you might wonder, what's this for, right? What's Beam for? And so an example of what Beam can be very useful for is, you may have applications that are generating a bunch of data. Maybe you have them running on phones or IoT devices, or you maybe have a web application that's generating events from servers, and these events are being streamed somewhere, right? And so you want to take these events and analyze them. And so, whenever you want to do something like that, it's you can leverage one of the systems, right? You can use Beam, you can use Spark, Flink, etc. So today, we're not going to use data coming from a system. The example pipeline that we're going to consider is a CSV file of COVID-19 related data. So we'll try to do some analytics on the data coming in from COVID tracking, which I'll mention a bit. And our goal here is to develop a pipeline that we can run, let's say, every night, and we can get some interesting insights from this pipeline. And so, for instance, we may want to figure out if there are sudden spikes in cases in some location, and then we may want to use this information to build a dashboard. By the way, a disclaimer is that I'm just a software engineer and I'm not a public health expert. So this is just for Beam education, but if you want insights on COVID-19, you should go to health experts. All right then. Now about our source data, in the repository, in the GitHub repository, I uploaded 3 different CSVs from data that I found while I was exploring the internet for COVID-related data. Data that I ended up using is from the COVID tracking project. It started as a group of volunteers, and now it's sponsored by The Atlantic, which is a publication in the US, and they're basically tracking COVID cases in the US, so they're indexed by state. I also found data from Johns Hopkins University, which is it's indexed, it's from the whole world. So it's indexed per country, and there's and per region in some of these countries. So that's also a very good source of data. But in this case, I was working with the COVID tracking project data. I also found data from the Mexican government, and I would have used that because it has very, very fine granularity data. But I had trouble decoding the file. So if you're curious about it, you can check it out. It's the largest of the files, and I'm sure it has good insights. All right then. So we have the CSV files, right, containing data about COVID-19, and so we wanna write a Beam pipeline where we analyze this data and get some insights, right? And so, what is the flow of doing something like this, right? As we saw in Beam, there's sets of transformations. So the first thing we want to do is reading the CSV file, right? Then when we do read in the CSV file, what we get is just a bunch of strings representing each line in the file, right? And that's not very useful for us when we're working with CSV data. What we want to be able to do is get rows represented by the CSV data. So what we do is we'll take the CSV file and we'll parse it into Python dictionaries, where we'll get for instance, the date, the state where the data was recorded, and all of the other particular columns. And once we've done that, then we want to clean up the data, right? So there's, for all of the data, there's some columns that there's some columns that we're not very interested in. There's well parsed, etc. So what we'll want to do is just clean up all of this data and get this cleaned up data. We can really dive in and analyze it, right? And so now let's get started.
Hello. Hi, Pablo. Seems like we lost you. Your microphone is muted.
Whoop, hello?
Okay, now you're back.
Okay, how?
I think we lost you probably 3 minutes, 2 to 3 minutes.
All right. Sorry about that. I didn't notice that that the tab had crashed. All right, I'll get back to sharing my screen. All right, let's see. So I'll go back. Were we on this slide, or had we moved on to this? Had we moved on to this slide? All right, I'll explain from this slide. Please let me know if I should go back. But anyway, so the flow of the pipeline will be, we'll read in the data from the CSV file. And so because we're reading a file, we'll get a bunch of lines, right? So we'll get a line, which is the header, and then a line for each row in the CSV file, right? Now, this is not very good for us, so we're going to want to parse this file into Python dictionaries so that we can process them as individual rows. Now, from each Python dictionary, then we're going to want to clean them up, right? So there will be columns that we're not very interested in. There will be other columns that will have dirty data that we'll have to clean up. And so we'll take in all of this raw parsed Python dictionaries, and we'll clean them up and get data that we can work with. And then we'll apply some fancy analysis to get some cool insights. All right. Now, reading data, right? So the first resource to reading data with Beam is the documentation of built-in I/O transforms. Okay. If you see on that website, Beam has transforms to read from all sorts of files, Avro, Parquet, text files, etc. Also file systems like HDFS, S3, Google Cloud Storage. We can also read from message queues, very useful for streaming, and from databases of all kinds, MongoDB, JDBC-related databases, etc. Right? Now, for this webinar, we will work on reading data from a CSV file. So we'll define a p-transform to read data from the CSV file. All right. So if you look at the GitHub repository, you'll find that there's this COVID Python little Python project that contains a small set of files. We have a pipeline file, which contains the main final pipeline that we'll build. We have a data source file. We have a data source test file, which is where we're going to write some tests for our Beam transformations, etc. Right? So what we're going to start with is we're going to write this data source that allows us to read data from CSV. Okay. All right, here it is. So I had mentioned earlier, right, that Beam has this abstraction called the p-transform, right? So let's define a p-transform class called read from CSV, right? And so here what we do is we want to subclass this p-transform class. And so as I was saying, the p-transform allows us to define logical operations that we want to apply to this data. So it has this operation called expand, right? Where it takes an input p collection or pipeline object, applies some operations to it, and returns a new p collection object, right? So in this case, because we're only starting the pipeline, because we're just reading in the data, what we want to take in for this class is a file pattern or a file name, right? So we'll say in our constructor, we'll take in a file name, okay? All right, we save this file name. So how would this work, right? So this transform receives a file pattern and returns a p collection of lines of oh, we want to read from CSV, so we want Python dictionaries, right? All right, so how will we do that? In code, this would look something like that, right? We have our pipeline. Oops. We have our pipeline, and we want to apply read from CSV, where we pass it a file name, right? So let's say my file named CSV, for instance, right? And this will output a, where the data might be will be a p collection of, Python dictionaries, for instance, right? And so on, right? So the input for this p-transform, when we apply it to a p collection, is just the pipeline, because we're just starting our pipeline, right? We're just reading our data in. And then, so what do we want to do first, right? We want to find the file that corresponds to this file. And Beam has a set of built-in transforms that help us do that. And so, because, by the way, our file pattern, our file name might be a file pattern, right? So we might receive a wildcard where we want to match multiple CSV files. Our file might be in S3, right, or in HDFS, etc. So it's good when we want to work with this sort of files to use a Beam transform. So first we'll get our P collection of input files, where we'll apply to this P collection this transform from Beam called match files. And so we apply it, and we get what this will return is a list of metadata from these files, right? It will be, you can think of a P collection of file names, right? And once we have this P collection of file names, we want to convert them into readable files, right? So what we do is we take this input files and apply yet another built-in transform called read matches. So first we get a P collection of file names, and then we take this P collection of file names and convert them into a P collection of readable files. And once we've done that, we can go ahead and convert that to, we have individual files that we can read in. And so Python by itself has functionality to read CSV files. So as we remember, each element in this P collection is a file. And so what we can say is the rows from this P collection of files, we can apply it a flat map operation where we'll take each one of the files, and we'll read it in as a CSV file, right? So what we do is CSV, there's a dict reader object from the Python CSV library that takes in a file and returns just a list of dictionaries, right? Now we need to wrap our files to a text.io wrapper for and we open it. So here we take our P collection of readable files, and we open each file and we consume it as a CSV file that returns dictionaries, right? And that's all we need our P transform to do. Now we can return our rows. So this is an example of writing a composite P transform in Beam, right? And so what does this look like? You have a file. The file is a CSV, so it has the header with the names of the columns, and then a bunch of rows with the contents for each column. And what we want is to get just Python dictionaries with the output from each column, right? So, whoops, I skipped a slide. Yes, we've written up the transform. Now, another interesting thing here, and one of the things that I want to cover, is how do we verify that this transform is correct and that it does what we want it to do, right? So basically, we have to write a test for it. So we're in the data source file. Let's move to the data source test file. And so this is, again, a normal Python project where you have your file and this file underscore test to write unit tests for the classes and methods in that file. So we're going to define this method called test read from CSV. Now, luckily, in the GitHub repository, I have a sample file called test data source. Where if we look at it, we have our 3 columns: country, continent, people, and we have some sample data of countries, the continents where they're in, and some approximation of how many people live in those countries. And so we can go ahead and write a pipeline for Beam that verifies that when we read this CSV data, we obtain the contents as dictionaries like this, right? So here's one way of writing a Beam pipeline. So we can use a with context in Python to define a context where we write our pipeline. So we're going to say we take this pipeline and we apply this data source dot read from CSV, and we're going to pass it the file name that we want to use, which is on the resources test data source, which is what we have here. Test data source file, right? So at this point we say, okay, we've read in the file into this P collection of rows, and now we want to verify that this P collection of rows contains, the same contents as the file, but parsed into Python dictionaries. Now this is a very good opportunity to use the Beam testing utilities. So Beam has a series of utilities in Apache Beam testing.util that you can use to add assertions and checks into your pipeline, right? So in this case, we're going to use this assert that construct. So we're going to say assert that the actual is the P collection that we want to test, and then we pass a matcher with rows. So we want to say that our rows are equal to the expected test data source file contents, right? So this is what we expect the transform to output once we read in this CSV file. All right. Now you might think, okay, well, this just looks like a normal assertion. But what's interesting about this assert that utility that we have in Beam is that it runs as part of your pipeline. So if you want to write a test that runs locally and tests a small transform, that will work. But if you want to run a test that will run on your production environment, be it Flink, Spark, Dataflow, this assert that transform will also run in that cluster and verify the output of your transformation. So once we have this, we can run the test, and it's fingers crossed. Right, the test passes, which is great. Now you might say, "Oh, how do I know that this did anything?" Right? So let's do something simple where we say, let's take this P collection of rows and let's apply a simple map transform where we print each one of the elements in this P collection. All right, does that make sense? Let's run it. We'll expect that the output from running the test will contain the individual elements in the P collection. And here is, right? So we have the country, the continent, and approximate number of people. Cool. Which also, if we wanted to verify then, for instance, that that the test would fail with incorrect data, we can do that too. So when we add extra incorrect data, our test will tell you that there's the assert failed and that there was a missing element from the actual P collection, right? All right, so yeah, so this is our first example of writing a transform and writing a test for it. Again, what's very useful about this is that you can take these tests and run them on your production environment. And my advice is to always write lots of tests, lots of unit tests for the transforms that you write in Beam. All right, then. Now we've read in the CSV data, and now we want to clean it up. So let me show you for a second what our data looks like. In this case, the data that we're going to use is this file called daily. So let's look at the first line in this file, we have a lot of columns. So there's date of the data point, state, positive, which is the number of positive confirmed cases, negative, number of tests that turn negative, etc. Right? And so let's take a quick look at what the file looks like inside. Let's select the date, the state, and the positive. So this is what the file looks like inside. So we have rows. You know, we're just selecting a few of the columns, but these are the 3 columns that we care about. We have a date, we have a state for, and we have a count of positive, you know, tests that return positive for COVID-19. And we have so we have one row per state per date, and you know, some count of positive tests. And so we'll want to probably clean up the columns to remove anything that we don't care about, and also remove any rows where one of these 3 columns is empty or misformatted, right? So in the interest of time, I skipped that part. And so if we look at the pipeline file, we define our pipeline here in the run method. We define our pipeline, we read in our input data, and then from here to here is where we clean up our data and we filter out columns where that have missing information that we care about. I won't dive into this transformation, but you're free to do so. Now, I will. I want to focus now on what sort of analytics we're going to do on this data. Now, before I move on, though, something that I skipped mentioning with our data reading transform is how do we verify the scalability for it? We verified the correctness, right? We ensure that it reads a file and that it returns Python dictionaries and that it's working correctly. But how do we know that it will work when we want to read 1 million files, right? Or when our files become 1 gigabyte, 2 gigabyte, 4 gigabytes long? Well, that's unfortunately not that simple. For people, it usually starts by trying out their pipelines in production and figuring that they hit a scaling, kind of a scaling limit, right? Something else that you can do is to write stress tests for your pipeline, right? So in a similar way, you'll write small pipelines and you'll mock out input data, and you'll just take your pipelines and see how they deal with all this input data, right? This is only useful up to a certain amount, because eventually you need to become familiar with the execution model, and this is the case for Beam and also for Spark, Flink, etc. So a good first reading point is the Beam execution model, and then check out also pipeline patterns in the Beam documentation, and just try to use built-in transforms. It's a big process for even for us developing these frameworks to write a transform, and then over time we call it battle tested, right? So people will go and try it, and the transform will have a scalability difficulty, and so over time we kind of have to figure out what are the ways to make our transforms more scalable. Anyway, so what I wanted to show you here is that in the Beam execution model, you'll find that these frameworks, they try to group operations that can be performed in a single worker without serializing data to be sent to other workers, right? And so this is useful, and it's generally a performance gain, but it can limit our performance because, let's say, for instance, we match a list of files, and let's say that each one of our files is 4 gigabytes, right? And we'll have, let's say, 4 files. So we'll have 40 gigabytes of files, and we'll pass them, convert them into readable files, and then we'll read all of the files, right? So in Beam, and this would be similar in other frameworks, all of these operations become grouped to be run in a single worker. And the problem that we would hit here when we would want to read multiple very large files is that we would get stuck reading all of the data in a single worker. So something that we have to end up doing in transforms like this is to add a transform called reshuffle here. And what reshuffle does, it'll say, okay, we found all of these input files. Now we want to spread them out, shuffle them around in the workers in our cluster, so that different workers can execute, process them downstream, right? Now this change to the transform doesn't bring any logical difference on how the transform behaves, but it'll have a physical difference on how it executes on the cluster. So my advice here is, again, write stress tests for your pipelines and just become familiar with the execution model. And even if you're not using Flink, Beam, you may use Flink, Spark, etc., and you'll have to become familiar with these execution models. All right, then. So finally, jumping to analyze data. Are we a little bit, how's time? All right, I'll try to finish in a few minutes so we have time for questions. So what sort of analytics can we perform on this data? I was trying to come up with an example of analytics that we could do on this data. And so I was looking at the New York Times page on the trends from COVID-19. And I was noticing that the data seems to have kind of a rough 7-day cycle where, on weekends, kind of confirmed cases dip, maybe because not so many tests are run, or because, I don't know, people don't go get tested, who knows, right? But so we have kind of 7-day cycles where we have different tests being run and cases being confirmed. So I figured we could look at the last 7 days for each state, and if the last day in this range had a much larger number of cases than the previous days, then we can think it's a spike. It's a spike higher than anything on the previous week, which means that it's trending upwards, right? And so I figured we can try to do that analysis. And so what we have currently in Beam is on our pipeline is we have all these Python dictionaries flying around in our cluster, and we want to be able to take the data that belongs together and analyze it together, right? So we want to take the data for each state and group it together, right? So let's go and compute a metric from our data. Let's see. Wait, this was in pipeline, in the pipeline file. So we have our filter data, and we want to get all data for each state together, right? Let's say data per state. Okay, we want to get the data for each one of our states together. And so what we want to do is we get the filter data, and we want to apply, what we can do to get this data together is a group by key operation, which is common in all of these platforms. And so currently this data doesn't have any keys that we have defined. So the first thing that we want to do is tell it, okay, we want to key this data by state, right? So what this transform with keys does is it takes in data and you pass it a lambda that will let you decide what will be the key for this data. And so it returns a P collection of key value pairs, keyed by, in this case, the state. And then once we have that, we can group it by their keys. So by doing this, we're grouping all of the rows that belong to a single state together, right? And so what this group by key returns is it returns a P collection of key value pairs where the key is the state, let's say Washington, and then we have just a long iterable of our data points, right? So we have state, date, whatever, right? Positive, etc., right? And so now we want to take the values, which are just this long iterable of elements per state, and we want to get that, right? So this will return us, instead of key value pairs, it'll just return us long iterables. So a P collection of these long iterables. And now, once we have a P collection of these long iterables, then we can analyze each one of them. And so we can do that. We go to the transform styles, and we'll define a function that will help us analyze each one of these state iterables, right? And so Beam has a powerful construct to define element-wise operations, right? So it's called a do fun, because it's a function that you do and apply to each one of the elements. And it has a process method. So in this case, the element, it's an iterable of dictionaries, where each dictionary is, maps from strings, which are the column names, to string, which are the column values, right? And so what we want to do, as I had mentioned earlier, is we want to find, for each state, the first thing we want to do is all values sorted by date, right? So we'll make the iterable of elements into a list, and then we'll sort it where the key equals the date, right? So we'll have the later elements towards the end of the list, and then once we have this, we can get the list of positives, right? So the sorted list of positive confirmed cases. So we'll do element positive for element in all values sorted by date, as long as, the column exists and it has some value, right? So then we'll have in this list just a count of positives. So these are cumulative. So we don't want to use cumulatives. So we'll get the differences, right? So we'll use NumPy, which helps us get kind of the derivative of this array. And once we have that, we'll just take the previous day positive differences. So we'll take the previous day and we'll compare it against max positives previous week, right? So we'll get the max number of positives from the previous week, So we slice it via Python slices. Is this correct? Right, should be fine. And all we do is if the number of positives today is larger than the max number of positives from the previous week, then we want to yield this, output this element, this row itself, right? So because they're all sorted by date, we know that the last row is the latest one. And so with this, we've defined a do-fun in Beam where we can take in our values and perform some, complicated analysis and then yield results. Now, once we have this and we have this data per state, we can apply. As you can see, I cheated and I already had coded part of this. We can find the spikes on these states. And then once we have the spikes for each state, we can write it out to a file. And so gladly, I prepared our pipeline to run, where we have an input file. Oops. Right, it seems like I have a bug. Now, because we're time constrained, I cheated here too, and I already had coded the function. So in case I might have missed something, let's try to run it with the new, more correct transform. All right, that ran. And so if we look at the command that we used, is we're saying Python run our pipeline, where our input file is this daily CSV, and our output is this output.json file. So we look at the output.json file. Oops. And we can see rows of states that seem to have spikes on May 12th. All right, then. We're almost out of time, so I'll skip the part from pipeline options. But quick review, we built a B transform, we built some tests for the B transform, we wrote a do-fun, and we ran our pipeline. We didn't have time to define options, but this is very simple, and you can see it on the slides and on the repository. Thanks. I have extra time, so I can hang out and answer questions. Questions about Beam, about the ecosystem, etc. I'll be happy to answer. I'll stop sharing. There's a question asking, can you join a streaming P collection to a static P collection? For example, you could be streaming in that has country names and you want to join with a country ID. Yes, you can do this. There is a construct in Beam called site input, and other engines have it too. You can call them kind of broadcasting a P collection. And yes, so you can read a static P collection or even a P collection that changes rarely, and join it with a P collection that is streaming in continuously. If you can, by the way, you can open issues, by the way, on my on this repository if you have questions that you want me to follow up on. But the answer for now is yes. Very observant. Is there a reason why we use yield on the do fun instead of return? What does this mean? Let me project my screen again. When we wrote this do fun, at the end, when we want to output the data, we're using yield. Why are we using yield instead of return? Well, the answer is a do fun allows you to define per element operations, right? And so you might want to return more than one element for each individual element that you receive. And so the expected output type of the process method is an iterable. So because you might want to return more than one output for each input. So with yield, you can do that. You could also return, instead of using yield, you can return a list of all of the outputs for each input, which in this case is just one, right? Yeah, that is why we're using yield instead of return. Let's see. How can we improve the scalability if the number of files is an issue? Oh, yeah, that's a good question. So it becomes kind of tricky. So you end up maybe having to partition your kind of your collection of files, right? So instead of having a wildcard for all of the files in this directory, you would have to have, let's say, 26 wildcards for the files that start with A, files that start with B, files that start with C, and so on, right? And so in cases like that, what you can do is just sub-partition your range, and it's not easy, but you end up having to do that, where you have to perhaps create a directory structure that makes it easier for you to partition how you read your files. Yeah, so basically you have to find ways to divide how you consume each of the files. Some cloud providers, I know Google does, can send notifications by a message queue when a file is written. So you can also use that, where if a file is written, you receive a notification, and instead of reading the file directly, you read the notifications from PubSub. Anyway, it becomes tricky, and so you start having to do tricks to read multiple files. Sorry, a very large amount of files. Question, why did we use the reshuffle in the p-transform? Yes, so in the reshuffle in that p-transform is allows us to reshuffle the individual file names. And so let's say that we find 1,000 files, right? If we didn't reshuffle those files, what we would end up doing is we would read those files from a single worker, because there would be one worker that checks the online directory, the distributed file system, finds 100 files, and then without serializing those files and exchanging them with other workers, it would start reading them. So what reshuffle allows us to do is to say, okay, let's reshuffle these file names to different workers, so that they can be processed separately by each worker. Question, can you read and write files to S3 if you're using the Dataflow runner? So I have not done it. I think the answer is yes, but you would need to deal with passing the credentials to the workers, which I'm pretty sure it's possible, but I haven't done it. So if you want to, if you're trying to do that, I recommend that you ask a question on Stack Overflow. We monitor the Stack Overflow channel for Beam and for Dataflow. Or you email the Beam user list, which is user@beam.apache.org. I'll put that on the slides so that you will have the access to that. All right. In a Dataflow context, would you use templates for production deployment, or would you use another means of running a pipeline? So in Dataflow, we have something called templates, which is you write a pipeline, and then you generate a file that is kind of a template for this pipeline, and you can rerun a pipeline from this file instead of having to rerun the pipeline program every time. And so in Dataflow, we have a lot of users that like using templates. And we also have a set of pre-provided templates that we test. And so if you have a use case that is covered by one of the pre-provided templates, I recommend using those. And then as for whether you should use templates on your own pipelines, well, that just depends on what your deployment story is. All right, question. Okay, so there's Pavitra asking, I have a use case where I need to read from Kafka topic, extract the topic name from the input message itself, transform the input message, write the message to the topic name determined dynamically at runtime from the input message. How do I pass the topic name dynamically to Kafka.write? Well, I don't recall how to use the Kafka.io. I haven't used Kafka.io, but so if you have very specific questions about how to use a certain IO for Beam, I'm presenting my screen again, please email the Beam user list, user@beam.apache.org question, or ask on Stack Overflows. The Apache Beam or Google Cloud Dataflow tag. I know it's intimidating to send an email to some random mailing list, but it's no big deal, and we love getting questions from users, and we'll be happy to answer your questions. Hello, very sorry. My computer crashed again. And can everyone hear me? I can no longer see the questions. The last questions that I was able to see is, does text IO have a reshuffle in there? That's a good question. So Beam has an older construct called source. So a source was not a p-transform. It was used by a p-transform. And what sources allowed you to do is to do this sort of reshuffling without having to insert an actual reshuffle. And so text IO is implemented as this source interface where you don't have to use a reshuffle. In the future, we're going to be using something called splittable DoFun. And so instead of using this source interface, we're going to be able to define reshuffles in our DoFuns, which is the functions in Beam that allow you to define individual kind of per element transformations. And you'll be able to say, okay, process this file in a different, allow this file to be processed in a different worker. But anyway, so no, text IO doesn't have a reshuffle, but text IO is able to rebalance on multiple workers. But on the other hand, text IO does not allow you to do CSV file parsing because it does not allow you to control how you consume each one of the lines in the file. Right. Another question is, after we group the data based on a key, is the data for each key processed in a single worker? Yes. So the unit of parallelism often in these systems is the key. So when you group the data by a single key, all of the data for that key will be processed in a single worker. And this can often cause scalability problems, where when you have just too much data for a single key that cannot be processed in a single thread. And so what people have to end up doing there is sharding the key, so adding an extra random component on the key so that they don't have to process all of the data for the same key in the same worker. but it really depends on the algorithm. The follow-up question to that is, can we use reshuffle on the group data? Yes, so I mean, if you group by key, you can reshuffle again if you need to, but it really depends on your algorithm. Sometimes you do need all of the data for one key to be kept together. All right. Is there any plan to providing a Scala SDK for Beam, or is Shio the way to go? I think Shio is the way to go. I work on Dataflow, and I know that, so Shio was developed by Spotify, and it's a sort of wrapper around Beam with lots of very smart utilities. It was developed by Spotify, and Spotify uses Dataflow, but Spotify is not the only customer that uses Shio on Dataflow. And so yeah, Shio is used, and it's a good framework. Question: in the finish bundle function in the doFun class, should it return an iterator, or is one element enough? That should also return an iterator. So you can have something that you can often do is batch the operations that you do in your process element, and output the result of batching them in your finish bundle. And so you may have to output multiple elements. So you should return an iterable. Okay, question: the reshuffle p transform seems to be deprecated in the Java SDK. Well, is there an alternative? The follow-up of the question is splittable doFun an alternative? And the answer is, well, it can be, yeah. So splittable doFun is not completely finished. If splittable doFun is, might fit your use case, please contact the user list. And you can, as far as I know, you can still, use reshuffle on the Java SDK. We use it internally at Google for some of our pipelines, so we can't get rid of it. So yeah, you can still use reshuffle. Another question. Oh yeah, just the reshuffle being deprecated. Oh, in the finish bundle, should it return an iterator or one element? Yeah, so we want to return an iterator. So a list is iterable. Sorry, an iterable. So a list can be iterated. So that's a good return value for finish bundle. Oof. All right, I think I've answered all of the questions that I've seen. This is being recorded, by the way. So if you're curious about the answers to previous questions, if you want answers to previous questions, you can check the recording. Okay, someone's asking, why do we need Beam here? Well, so in this case, because our data is pretty small, yeah, we could just do it with NumPy. But as data becomes very large, which is why I wanted to use a data set that had more granular data, then data no longer fits in your memory, and so you end up having to write transforms that will have to be executed on a distributed cluster. But yeah, you're right. So when the data is small, you can just use NumPy or pandas or whatever. All right then. So I guess that's it. I think there's no more questions. So I guess I'll sign off. Hi, Jamal. Do you wanna close it up? We can't hear you. You might be muted. Oh, all right then. It seems Jamal is gone. So yeah, I guess we can wrap it up. Thank you very much for for coming to the Beam Learning Month. We're going to have another talk next week by Ismael, who is also a PNC member in Beam, about how to use the Beam with the Spark runner. So now you can start looking into how to run your pipeline at large scale, and why for some use cases you can't just use NumPy, and you have to really look at this large scale frameworks. All right, thank you very much. See you next week, same time, to talk about how to run Beam on Spark. And if you have any more questions, please send them to the user list. Hi, Tobias. I will save your question, Tobias, and we can follow up. You can email the user list or